Next we have grooved rolls, and they can be made. There's two types. There's rigid grooved rolls and flexible groove rolls. We're going to talk about both. Groove rolls can be made from a wide variety of materials, and really groove designs vary greatly in the industry. They can be something as simple as we've probably all seen, where operators take, let's say, tape, and they spirally wrap it from the center of the roll face out towards each edge. I guess that could be considered some type of a grooved roll, all the way to very intricate machine grooves as well. Wrap angles around grooved rolls range between 90 to 180 degrees. Now, as I said, groove designs vary greatly in the industry. This is just an example of one type of grooved roll. I'd like to call attention to the area of the grooved roll where the grooves come together and they meet in the center into that V shape. That's called a start. So if you're speaking with somebody about grooved rolls and they mention a certain number of starts, they're talking about how many of those V points meet around the full circumference of that roll. But the theory of operation, quite simply, for grooved rolls is that the grooves will push wrinkles as the roll is rotating. The grooves will push wrinkles from the start, or from the center, out towards each edge. Now, when a grooved roll is used as an idler roll, it's extremely useful where air entrainment is a problem, because it does allow the air to exhaust from between the web surface and the roll face. They're pretty easy to get, relatively inexpensive. Most roll manufacturers make some form of grooved roll. As with any other idler or driven roll in your machine, they're easy to maintain, and they have a linear face, so they won't stretch or distort any portion of your web. And they're used a lot in textiles and nonwovens. Really, their theory of operation isn't accurate, and I'm going to cover that in the next couple of slides, so I'll save the explanation. Their surface is linear, but it's not smooth, so they do have the potential to mark or scratch the surface of some webs. And sometimes, depending on the severity of the groove or how much groove profile there is built into the roll, sometimes, and also depending on the extensibility of the material, sometimes the material will form down inside the groove, and in that case this roll could cause wrinkles. So they really have limited applications with light papers and foils and films. Now, theory of operation for a groove roll really isn't accurate. Basically, what I'm trying to show in this slide is that as the roll rotates, the wrinkle remains in a constant position with the groove through the roll's rotation. So when the web and the groove travel at the same speed, or when the web is synchronous with the roller, really that groove has no effect in pushing wrinkles to either side. So a lot of people believe that groove rolls are working in their operation, I think mostly based on, for lack of a better term, the optical illusion of when you see these rolls rotating, it looks like they're pushing wrinkles out, because you can see the grooves. They look like they're moving from the center out towards each edge, but in reality they're not. It's sort of like the stripe on a barbershop pole. As it's rotating, looks like the stripe is moving, where it's in a constant position relative to the barbershop pole. Same kind of thing here. The web stays in a constant position with the groove as the roll rotates through its rotation. Now, groove rolls can be used as a dead bar, or they can be driven at a different speed than the web. And when that happens, you do gain the benefits as when it's used as an idler roll, but then the grooves will push wrinkles in the direction that they're facing. What I'm showing in this slide is when the web is bolted in place or held in place and not allowed to rotate, the tangent point of the web, where it first touches the groove roll, drags around the circumference, and that tangent point is ever changing relative to the groove. So in that case, the grooves do push wrinkles out towards each edge. So if the web is non-synchronous with the roller, either the roller is being driven faster than the web, or the roller is completely locked down, or even being driven slower than the web, the grooves do have an effect in pushing wrinkles out. But you'll get more marking and scratching of your web because the web does have to slide around the circumference of the bar. And you could have other wrinkling problems downline or edge guiding problems downline because the web at that point is not in traction with the roll face. It's not in traction with that bar because it's sliding around the circumference. So when it's not in traction, it can move from side to side, and that could cause you wrinkles or, again, web guiding problems somewhere else in your machine. Now, there are groove rolls that have a soft rubber surface, and basically they have their surface is soft enough to flex under web tension. And there are flexible lands that move when web tension is applied to them. Wrap angles around these rolls range between 30 to 180 degrees. Now, the theory of operation for this roll is that when you apply web tension, these flexible lands, these soft rubber flexible lands, literally lay down in the direction that they're facing. And that flexing action, that groove movement, that flexible land movement will push wrinkles from the center out towards each edge. One of the things that you'll notice if you use these rolls in your plant is that the groove depth, if you look at the groove depth, it's kind of hard to see in this slide, but it gets a little deeper as you measure from the center of the roll face, which is right here, out towards each edge. And the reason for that is each flexible land will flex a little bit more than the one next to it. So these flexible lands, because that groove depth is very shallow, won't flex as much as the one next to it. And then, so this one will flex a little bit more, this one will flex a little bit more, this one will more, and so on all the way across the roll face. That provides for even spreading across the roll's face. They are useful where air entrainment is a problem because the groove profile does allow the air to exhaust between the web surface and the roll face. They have a linear surface, so they won't stretch or distort any portion of your web. They have a soft rubber surface that won't mark or scratch your web. And these rolls are used a lot in the converting industry with all types of webs and all types of applications. Disadvantages, since this roll's surface relies completely on web tension to flex it, as the web is leaving the roll, web tension is being removed, and those flexible lands have to spring back to their natural position. So they could have the effect of pushing some wrinkles back in, because as the web is leaving, you're taking tension off the roll face. Those flexible lands are springing back, and that could push some wrinkles back into your web that the roll took out. Depending on your material, the extensibility of material, and also again how and the profile of the groove itself in these rolls, sometimes the material will form down inside the groove, and that could cause wrinkles.